2.2c. I'm going to give you some limit tips because you're going to get all different types of problems. Okay, so the first one is factor when possible. Factor your limits when possible. Then you ask yourself, is what you're looking at continuous? If it's continuous, it's easy. You can just evaluate it. Okay. Then if you have two letters, let's say h is a variable, we're going to look at h is a variable, in which case x is a constant. So we treat it like it's just a number, a constant. Okay? Now, while doing these problems, I'm just going to give you a warning when you're doing this homework. If you get something like this, the limit as x approaches 0 of something equals 0 over 0, make sure to think again. You may have forgotten to factor. Okay? So let's do some random problems, see how you do. All right? I'm going to give you, I think, 4 different ones. So here's an example. We have the limit as h approaches 0 of 3x squared plus 3x h plus h squared. Okay? All right? So what we can do is we can separate each one of these. We don't have to write them separately. We can treat them separately. But if you want to write them separately, you could write each one of these like this, plus blah, blah, blah. But to save some time, we know that with these plus signs, we're going to evaluate each one separately. So looking at this one first, x is a constant. And here we have h approaching 0. So we're just going to have 3x squared as the answer for that one. Bring the plus sign. X is a constant, h is 0. 0 times this is just 0. Okay. Here h is the variable. So we put it in and we get another 0. So our answer is 3x squared. Okay. Here's another example. The limit of 3 as x approaches 1. Now x is approaching 1. This is a constant. And we said the limit of a constant is that constant. So the answer is 3. Okay, let's do another one. The limit of x squared plus 3x minus 2. Okay, as x approaches 3. Again, we have this plus and minus. We're going to evaluate each one. So we put a 3 in the x and we get 9. 3 in this x and we get 9. And this is a constant, negative 2. So we have 16. Okay, let's see if I have another one. I do have another one. So I'm going to leave this up here for you while we go and do this one. Okay, so here's an example. The limit of x squared minus 8x all over x squared minus 7x minus 8 as x approaches negative 1. So I'll give you a moment to write that out. Okay, so we're going to go ahead and go by our list. Factor. Is this factorable? Well, yeah, we have 2 x's. Let's see if it goes anywhere. We'll factor out an x on top, and we get x minus 8. And we factor what's on the bottom. I'm going to presume it's x minus 8. X, let's see, what would it be? Would it just be plus 1? X times x is x squared. Outer is negative 8. Inner is plus 1. So that's a negative 7. And last times last, negative 8. So yes. Okay. Now look what happens. If we take the limit as x approaches negative 1 of x over x plus 1, if we just go ahead and put that in, we'd get 0 on the denominator. But does that mean it doesn't exist? Probably so. But let's say we want to test it. Okay? I'm going to go ahead and test. All right, we're going to look at -1 from the left and -1 from the right. All right, just putting in numbers. From the left, if I put a -3 in there, we're going to get a -3 on the top, -2 on the bottom, and we get 1.5. All right, I'm going to put a -2 in there. If I put a -2 on the top, we get a -1 on the bottom, we get 2. So far it grew. Let's see what happens when we put a -1.5. We're getting closer and closer to -1. We get, excuse me, -1.5 on the top and -0.5 on the bottom, which equals 3. So this is going to infinity. Let's look at one from the right. Let's start with a +3. If we put a 3 in there, we're going to get a 3 over 4.75. If we put a 2 in there, we're going to get 2/3. Oh, look what's happening here. If we put a 1 in there, we get 1/2. So what's happening to it? Put a 0 in there, we get a 0 over 1, which is 0. If I put a -0.5 in there, will I go to infinity? -0.5 over 0.5 is -1. So yes, this is going to infinity. So this, we can say, does not exist. Okay, one last one, and we are done with this lecture. Okay, so this one's going to be a little bit more complicated, but you're ready for it now. The limit as h approaches 0 of 2 over 3 plus h minus 2/3 all over h. Okay, so I'll give you a moment to write that out. Okay, let's say that we want to put these two together. We need the same denominator. The same denominator is going to 3 times h. So here I'm going to multiply 2 times 3. And this becomes 3 plus h times 3. So I multiplied the bottom and the top by 3. Now we're going to multiply this by 3 plus h. So we have 2 times 3 plus h all over h. All right, same denominator, 3 times 3 plus h. And here we have a 6 minus, I'm going to distribute this negative with this 2. Okay, so we distribute this -2 to both of these. -6 and minus 2h all over h. All right, our 6's go away. Okay, so we have the limit as h approaches 0. And we're going to have -2h over 3 times 3 plus h divided by h. Okay, so that's the same thing. And I know I don't like to keep writing limits, and I know you don't want to keep writing limits, but we have to. Okay, so divided by h is the same thing as multiply 1 over h. So we're going to equal -2h over 3 plus h times h. Our h's are going to cancel out. Okay, so these h's cancel out as h approaches 0 of -2 over 3 plus h. Now h is approaching 0. We've factored, we've canceled, we've done as possible everything we could, and we're done right here. Now h is going to 0. So 3 plus 0 is 3. So our answer is going to be -2/9.